Hey guys, welcome back. So today I brought home this Generac XG10000e. Now this is a decent machine. It's powered by a Generac made V-twin engine and brand new, sells for over $2,000. With that said, this is not new. It's about 3.5 years old and has quite a bit of hours. On the clock there, it's 1,566 hours. So this thing was used in construction for that 3.5 years until it stopped making power. So that's how I ended up with it. Now, I only spent $200 on this, which is about the cost of the carburetor alone. So worst case, I'll make my money back in parts, but hopefully I can bring this one back to a good, healthy state where it makes power. So I'm gonna start with the basics. We'll check the ohms on the main windings. We'll get the power head cover off and see what's going on in there. I'm gonna test the ohms of the main winding through the 240 volt outlet. Now you can do that on any 240 volt outlet, but in this case, I'm gonna use this one. Now, right here, there's like a tab, and that indicates the ground wire. So opposite of that, you have neutral, and then leg 1 and leg 2. So I'm gonna stick one of these probes into the neutral, and then one of the legs. The last one I checked was around 0.3, and that was on a good Generac XG10000e. As you can see, we're at 0.2, so that's a good reading. We'll try the other leg. And pretty much the same. So no red flags here. Now this is a low voltage test, so it doesn't guarantee anything, but if it was open lead, which on my meter is indicated by a blinking 1, or the resistance was really high, like say above 0.5, then you might have a problem. Actually, you do have a problem, but in this case, it's testing well. Doesn't mean it is well, but it's not bad. So let's move on to the power head. Yeah, these screws are already loose. So someone's already had a look. I've got to say, this looks really good. The last one I opened up, the last Generac XG10000, that generator only had 50 hours on it, and this one actually looks better. So, that's good news. Now, there are brushes down here, so I'm going to pull the wires off. Just take note that the blue one's in front, and I'm going to test the ohms through the brushes to the rotor. Now, I don't know what the ohms reading should be on this rotor, and I'm going to be testing it through the brushes. So if the slip rings are dirty or the brushes are bad, that's going to affect the reading. But I do like to check it through the brushes because that tells me how bad are the brushes and the slip rings. Now, going to the slip rings direct, most of the generators I work on should have a value between 50 and 70 ohms. And this one, I don't know actually. So, hopefully it's close to that range. If it's open lead or really high, like over 100 ohms, then we have a problem. So let's see what this one comes in at. Yeah, that's a good reading. That's 37 ohms. So I think the rotor's good, the brushes are good, stator main windings are good. So things are looking pretty positive here. starting to think that maybe we're just dealing with a bad AVR. On this generator, the AVR, or the voltage regulator for that rotor, is actually behind here, not down on the generator head. So I need to get these screws out, and this panel will come forward a bit so I can kind of get a peek in there and see what's going on. As you can see, there's a lot going on under here. We have a relay right here, potentially another one down there. We have a board tucked away in the back, and we got this one right in front. Now, I think this is the one in question. It has a potentiometer, I assume for adjusting the voltage, a status light, and it looks like about 8 wires, actually 9, coming in and out of this board. So I'm going to take a minute, just pull up the wiring diagram and see if I can't figure out what goes where, and maybe there's a testing procedure for this module. Did a little bit of homework, and although I didn't find a service manual, I did find a wiring diagram. So I was correct, that module is the voltage regulator, and I've kind of color-coded the different wires going into it. And what I wanted to do next is actually just check the ohms to the DPE winding, which is this pink one here. And also the yellow wires are what go down to the brushes. So I wanted to measure, again, the resistance from here to the brushes, expecting 38 ohms. So I went to reconnect the brushes so I could do that test, and ended up pulling the brushes off for 2 reasons. One, I wanted to see how much meat was left on these. And these things are in very good shape given the hours on this generator. So they've probably been replaced at one point. And the more concerning thing to me when reconnecting the wires is that this terminal is loose. And so is that one. So the fact that they're both loose, I'm guessing that that's just a feature and not a flaw. But the more concerning thing was, before I pulled this off, I checked the ohms again, and I was at 120 ohms, and I couldn't get back to 38. So I think the slip rings are pretty dirty, and given the amount of hours, I'm sure they're dirty. So I'm gonna try to get the camera in there just to show you the current condition of the slip rings, and then I'm gonna spend a minute just to clean them up and put the brushes back on and take another ohms reading. And they haven't made it very easy to access these slip rings to clean. So I'm going to use a piece of Scotch-Brite. I have both spark plugs removed for, I guess, A, safety. I don't want this thing accidentally starting when I am rotating it, but also it'll make it a lot easier. So what my plan is here is to just take the Scotch-Brite, put it on the slip ring closest to the bearing, just press it firmly while rotating the engine, and just do that for a bit, and then I'll move over to the other slip ring and do that one as well. Okay, get the brushes reinstalled. See if the ohms are any better. Beautiful. So almost no loss going through the brushes now. And we were at 37 before, and then I couldn't get even close to that. It was over 100. So it could be as simple as something as this as far as why this thing won't power up. But anyway, I'm going to continue with the test up there, and then we'll get this thing outside, test it as is. Who knows? Maybe I fixed it, but I kind of doubt it. So okay, so I want to check the wires going to the brushes first. So these two here are the ones that go to the brushes. Actually, the blue wires go directly to the brushes. This one is just a ground. So if I connect one lead here to the blue and another one to ground, I should see close to 8 ohms, which is what we get when testing directly on the brushes. And we get 8.5, so that wiring is good. Now, what I'm most suspicious of and why this thing won't power up is probably the DPE winding, which are these two right here. This comes from the stator and it provides power to this voltage regulator to power up the rotor. And generally it's around an ohm, give or take half an ohm. Yeah, that's the problem, I think. We're at 3.4 thousand ohms. So this is never going to power up with that kind of a rating. So I'm going to do one more check here. This wire here actually goes directly to the winding in the stator. This one's fused. So I'm going to pull this terminal off, test directly here, and then the other end is on the fuse, which you probably can't see right here. So I'm going to pull that off, pull this off, and we'll check it again. Okay, so I got one end here, which was removed from the voltage regulator. And I'm just going to put the other lead here on the other end of this coil. And we get the same reading, 3.47 thousand ohms. So that's probably it. I'm a little bit surprised because that stator looks to be in pretty good shape. I think I'm going to put this back together. I want to bring it outside, start it up, and just check what we get for voltage at the outlets. And yeah, that might be it. Okay, gonna fire this thing up and just check what the AC output is. Okay, well the good news is the engine sounds pretty good. On the voltage side, it's even less than I thought for volts. It was like 0.7 volts, and that's across the 240 legs. and half that on the 120. So that's not good. You know, I was hoping to at least see 4 volts. And I did try flashing it real quick with the drill, you know, no response. So kind of makes sense. You know, if the DPE winding is fried, it's not going to power up on its own. So I am going to disconnect the brushes and get a 12 volt battery and apply that to the brushes and see what we get on the AC side. Okay, so this is the setup. I've got 2 alligator clips hooked up to the brushes. The yellow one's the positive one closest to us, and the white is in the back. And that is running through a fuse and then to the battery. So when the engine's running, I'm going to connect it and see if the light turns on and what comes out on the 240 volt side of things. Also, I have another meter hooked up to the brush wires. I want to see if there's any DC volts making it down to the rotor when I'm applying 12 volts manually. Okay, well that result was both good and bad. You know, the stator main windings tested good, so I expected to get voltage out. And so did the brushes and rotor, and that's what we saw. Now, when supplying 12 volts, we got 200 volts on the 240 outlet, and I assume half of that on the 120. It was enough to make the light bulb light up. The surprising thing is, we were getting DC output on the wires coming down to the brushes. It was 150 volts, which is about 12 times the 12 volts that I was putting in. So if that had actually applied that much power to the rotor, we'd see about 2,000 volts out on the 240 and 1,000 volts out on the 120. So I'm not sure what was going on with that, but good results nonetheless. So the next thing I'm going to do is just pull that panel off. I'm going to pull the DP winding connections off of the regulator and also the sense winding. I want to probe those for AC volts, you know, start this up again, apply 12 volts and see what we get for output up there. Okay, and here's the setup for this test. We've got the DPE winding pulled out as well as the sense winding, and they're both hooked up to meters. We got the one here on the left is the DPE, and the one on the right is the sense. They're both set to AC volts. And same setup with the battery and this voltmeter on the 240 outlet. Now I've also added an amp clamp, which is zeroed out mostly. And I just want to see how many amps this is pulling. It should only be about 1.5 amps DC going into that rotor. So let's get it started again. We'll check all these meters and see where things are at. Okay, good. It was 1.5 amps, I think, pulling to the rotor. That's correct. Now, the DPE winding actually was supplying plenty of power. The sense winding, that was 0. So I didn't expect to see that. Yeah, maybe if it can't sense anything, it doesn't output power to the brushes, but we did see that it was putting out 150 volts to the brushes. So I think the plot thickens. Anyway, I'm going to pause the video here, do a little more homework, and turn you back on in a second. Okay, got a game plan here. I don't have a service manual for this generator, but I do have one for a Generac Guardian series, and that has an extensive troubleshooting section. And the principles in there can apply to many different types of generators. And that manual suggests in this scenario where we have a normal amp draw from that 12-volt battery into the rotor, and then we get over 60 volts out on the outlets and on the DPE, but nothing on the excitation winding, that really the next place to go is testing the insulation with a high voltage tester. And I don't have a high voltage tester. I only have a low voltage, but that still might identify the problem. Now, it might not. And if that's the case, then I'm kind of at a dead end. But to do this test, you have to isolate the coils. So that means removing the hot wires from here, removing the neutral wires for the leg 1 and leg 2, disconnect the DPE and isolate it, and disconnect the sense and isolate it. Once that's done, we're going to check each of those 4 coils to ground. And if that's good, we will then check each coil to the other coils to see if there's anything cross-connected due to an insulation failure. So I'm going to get these wires disconnected and we'll resume with those tests. Okay guys, I'm on to something, and I think it's good news. Now, I disconnected everything like I said, so the main windings, L1, L2, and L1, L2 on the other side on the neutral post. Also unplugged the DPE wire from the fuse and the other DPE from the regulator, as well as the sense windings. And I was just going to start again, just check the ohms of the DPE, and I get nothing. Before I was in the thousands. So by isolating the coils, it definitely changed what I'm seeing here. So I started poking around, I checked ground, nothing, main windings, nothing. And then I went over here to the sense. The first one, nothing, but the second one, we get 1.4 ohms. That's what I was expecting to see on the DPE coil. So someone made a mistake here at some point. This wire does not belong on the sense. So what they had done was they'd put one DPE and one sense on the DPE connections and one DPE and one sense on the other. And that's not going to work. Now, if I check this other winding here, which apparently is the sense, and connect it over actually to the DPE, well, it was in the DPE spot on the fuse. We get a number that's very close to the main winding, and that's what I would expect to see on the sense winding. So I need to get this off, relocate it to where it should be, and flip-flop some wires, and this thing might work. Okay, so now the sense is good. And so is the DPE. Excellent. So I'm going to reconnect everything. I'll test it one more time just to make sure. Okay, everything's reconnected. I'm just going to check now the sense winding, which should be around 0.3 ohms. And it is. And the DPE winding, 1.4 or 1.3. So those numbers are exactly what I would expect. Yeah, maybe that's it. It'd be nice. Okay, it's time to place your bets. Is this going to work or fail? And potentially in a spectacular manner, but I don't think so, based on what I'm seeing. This has got to be better. I would say more likely than not, it'll make power as long as nothing got fried when it was hooked up wrong. So we've got the multimeter hooked up to the 240 leg. I've got a light just in the 120 with the kilowatt, and I've got a drill just in case I got to flash the field. So let's get this thing started and see what happens. It works. Nice. Voltage is low. Hertz are low too. Let me try to bump that up a bit. I'm kind of shocked. I mean, I thought it would work, but there's always that doubt. It would have ruined my day for sure, but I had almost given up on this thing based on the test results earlier on. And as you can see, this thing makes power. Now, the voltage was quite low, so I had to turn this screw clockwise quite a few times, got it up to 120 volts. And the engine speed I need to turn up a bit. The adjustment's actually down here, which this is in the way, and this kind of broke loose a bit and fell down, and of course there's a bunch of live wires here, so had to shut it down. I think at this point we're pretty much done in here for now anyway. I'm gonna put this back on, start it up, and set that engine speed. All right, so to adjust the governor speed, it's kind of buried way up here. Let me see if I can show you. Yeah, you can just see it. That screw right there, it's actually a bolt. So I got to turn that clockwise to get the engine speed up. So that's what I'll do, bring it up to about 61.5 hertz. And once we get a good engine speed, we'll come over here. I've got a 30 amp breakout cord. It actually brings 2 legs over, so a total of 60 amps. And we'll load it up with 6,000 watts. See how the engine does. Yeah, not too bad. Okay, it did pretty good under load. You know, when up to 6,000 watts, it settled at around 58 hertz, which is a bit lower than I'd like, but 6,000 watts was also more than half load. So it might be normal. I mean, usually with 3,000 watts loaded on a generator, I see a drop of about 2 hertz per 3,000 watts. So in this case, we dropped, about 3.5 hertz. So I think we're in pretty good shape, especially given where we started. I mean, this thing I thought was just going to be parts. I mean, I was ready to take it apart and list some stuff on eBay. So I'm glad that this thing came back, and given the amount of hours on the engine, I think it's doing pretty good. So, about a year ago, I did fix another one of these. I'd only had 56 hours on the engine. I'm going to double check the footage, see if I captured anything as far as, the hertz drop under load. But regardless, I think we're in pretty good shape. Now, I haven't even given this much thought as far as what does it need, because I didn't think I'd get to this point. But, I have checked pretty much everything, and I don't think we need anything, other than that new battery I put on. The oil is full and clean. Air filter looks good. Plugs look good. I'm probably going to get the gas out. I don't know anything about it as far as its age or whether it has stabilizer. And I guess the only other thing, which is pretty minor, we're missing stickers on each side. So I might take a quick look, see if those are available. And yeah, I think we're just about done. Oh, and the charging system. I did check that the battery was charging, and it was charging at like 13.5 volts, which is decent. It's not too high, and it's not going to burn the battery out. So yeah, this one is a survivor. Kind of surprised me. So get this thing back to the garage and do what I can to make it as perfect as I can. Yeah, that fuel shutoff is no good. It happens a lot, so I'm going to replace that. Yeah, not sure what to make of this. The gas is green. Potentially some two-stroke oil is mixed in. Yeah, I'm not sure. Got about 5 gallons of that green stuff out and replaced it with some fresh stabilized fuel. Besides the battery that I had to replace, the only other thing that really needs to be replaced is this fuel screen. It's blown out here on the bottom, so I've already got a new one of those on its way. Now, when I bought this, I was told it was being used, the power went out, and that was it. They put it up for sale. But clearly, there's more to this story. The wires were in the wrong spot. The AVR was adjusted improperly. And that stator looks suspiciously new. So there is definitely a story here. Unfortunately, I don't think we're gonna ever know what that is, but I'm happy that the mystery has been solved. And you know, this thing lives again. I was fairly certain that I was gonna be parting this out on eBay, but I hate doing that. Would much rather fix something, even if it's breaking even, than parting it out. And in this case, you know, new stator would have been $800. I already have $200 invested in it. And yeah, I mean, maybe these do sell used for quite a bit, you know, $1,000, $1,200, but this has 1,500 hours on it, and that's not gonna fetch that kind of money. So that really wasn't an option. Anyway, it's running well now. It's doing what it should. And I think I'm done. So I hope this video helps someone. Thanks for watching. What do you think? Put the green gas in the John Deere? Matches.